Okay, I wanted to give you guys another example of balancing equations. This trick I want to show you guys is keeping polyatomic ions together. So the only way you can use this trick is if you have a polyatomic ion on both sides of the equation. So for example, right here we have phosphate on both sides, so we can keep our phosphates together. We don't need to split it up into P's and O's. We also have NH4 here on both sides, so we can again keep those together instead of having to split this into N's and H's. You don't have to use this method. I personally just think that it's easier and helps you to go faster as time goes on. So just like I always do, I'm going to go ahead and I'm going to break this up. I'm going to say NH4, oxygen, hydrogen. I got hydrogen, I got phosphate, I have ammonium, which is NH4, I have phosphate, which is PO4, I have hydrogen, and I have oxygen. I have one oxygen there, two hydrogens there. I have 3 NH4s. I have 1 PO4. A ton of people make that mistake. They think that there's 4 PO4s. No, there's 4 oxygens inside of the PO4, but there's really only 1 PO4. Right here I have 3 hydrogens. I have 1 phosphate, 1 NH4, 1 oxygen, 1 hydrogen. So usually I start with metals. There's no metals here. I'm probably just going to start with NH4. So I have 1 NH4 on the left side. I have 3 on the right side. I want to multiply that 1, the smaller number, by another number to be able to get equal to this 3 here. So I'm going to go ahead and I'm going to put a big 3 right here, because when I distribute this 3, it's going to become 3 NH4s, 3 oxygens, and 3 hydrogens. So now my ammoniums are equal, right? I have 3 on the left, 3 on the right. Now I can move on to my phosphates. I have 1 phosphate on the left and 1 phosphate on the right. So I'm chilling, right? Next I can move on to hydrogens. I have 6 total hydrogens that are separate right here. And I only have 2 over here. So what do I need to do? I need to multiply this water by 3, because when I distribute that 3, this becomes 6 hydrogens, this becomes 3 oxygens. I have 6 hydrogens on the left, 6 hydrogens on the right. Finally, I need to check my oxygens. I have 3 oxygens, so I'm chilling. Double check everybody. Ammoniums are happy, they have 3. Phosphates are happy, they have 1. Hydrogens are happy, they both have 6. And oxygens are happy because they both have 3. Remember to pay attention to when you have blanks. A blank does not mean 0. A blank means 1. We're just lazy. So if you see a blank, you should automatically assume, oh yeah, this is technically a 1 right here. I'm just lazy. Okay? So hopefully that method helps you go way faster instead of having to break up your polyatomic ions when they're on both sides of the equation.